In the last lecture, we studied the transducer definition and types of transducer. Now, in this lecture, we will study the LVDT, Linear Variable Differential Transformer, LVDT, and strain gauge. Now, first let me explain about the LVDT. LVDT is full form is Linear Variable Differential Transformer. Now, this transducer is used to measure the displacement. Now, this LVDT will convert the displacement into electrical signal. Output is a voltage. Now, let me explain the construction first. It is having the two winding, one primary which is connected to the AC source. Now, this is the AC source, and it is having the two secondaries which are wound on a hollow cylindrical former. Now, these two windings, these two secondaries are wounded on a hollow cylindrical former, and these two windings are connected such that now here, because of this AC, this primary will produce the flux into this air, and it will secondaries will link those linked by the flux will be linked by the secondary, and EMF will be induced in the two secondaries. Now, here the final total output, the EMF induced in the first secondary is E1, and EMF induced in the second secondary is E2, and the total voltage E0 is equal to difference of these two, E1 minus E2. Now, in this hollow cylindrical former, so core is a soft core is mounted, and this core is movable to downwards and upwards. When this core is placed exactly center, at the time the flux induced in this secondary 1 is equal to the flux induced in the secondary 2. Thereby what? The output voltage is equal to 0 volts. So, when the output voltage is 0 volts means what? This core is exactly placed at the center. If this core is moved towards to down, then here the flux linkage in this secondary will be more, thereby the EMF induced in the secondary 2 will be more than the secondary 1. So, thereby we get the negative voltage if the core is moved downwards. If the core is moved upwards, then the flux linkage in the first primary is more than the second primary, thereby the EMF induced in the first primary is more than the secondary. So, then that E0 is equal to in the form of positive values. So, when we getting the positive values, the core is moved towards to the up. If we are getting the 0, then the core is exactly placed in the center, and if we are getting the negative values, then the core is moved to the downwards. So, like this displacement of this core is converted into electrical signal. Now, for this, if I take the graph, this is at 50% at null position, and this is 0 downwards, and this is the upwards. This is the displacement, and here it is EMF. And here residual voltage, I am not showing the residual voltage. Actually, we don't get exactly 0 volt here. Some minimum voltage is there, that is called the residual voltage. But now here I am not showing that. Now, when exactly at center position, the voltage is 0. If it is moved to the down, then it is negative voltage. If it is moved to the up, it is a positive voltage. Now, this is about the LVDT, which will convert the displacement into the electrical signal. So, how much electrical signal we are getting? So, what is the polarity? Depending upon that, we can analyze the displacement. And the next one is coming to the strain gauge. So, strain gauge is a transducer which converts the strain into the actually here it will convert the strain into the resistance. Directly it is not giving the electrical signal. This is the best example for the passive. This is a passive transducer which is needed the external supply to convert that resistance into the electrical signal. And also we can give the example. This is the example for the resistive transducer. Now here you can see if we take one conductor or semiconductor and if you apply some strain on that, then the shape of the electrical conductor will change, the conduct shape will change. Now here R is equal to rho L by A. Now if the length of the conductor changes, if area of the conductor changes, thereby the resistance changes. Then we apply the strain, then the shape of the conductor will change. So thereby what? Length or area, both the parameters may change, thereby the resistance also changes. So that resistance we need to calculate. That resistance is directly proportional to the strain. And here this resistance we are calculating by using the one bridge circuit. Here if you see, we applied the external supply to convert this resistance into voltage. Now here the strain gauge is connected. Now if all the resistors are equal, then the voltage is 0 volt. Now if we apply the strain on this, then the resistance of this wire will change. Thereby here the voltage will be induced. This voltage is directly proportional to the resistance, and that resistance is directly proportional to the strain which we applied. So strain can be calculated in the form of voltage by using this bridge. Now what is the strain? Now if we apply the strain on the electric or conductor or semiconductor, then the length will vary. So if the length is L, this L will vary to the L plus delta L. So this is a change in length. So this change now S strain is equal to delta L divided by the L. It is a ratio of change in length to the length. This is called the strain. And thereby by applying the strain, the resistance also changes. If initially the resistance is R, then it is going to be changed by R plus delta R. So this is the change in resistance. Now the sensitivity of the strain can be calculated by using the gauge factor GF. Now what is GF? GF is it is a ratio. It is defined as the unit change in resistance unit change in resistance per unit change in length. That is nothing but a gauge factor is equal to delta R by R by delta L by L. Now here delta L by L is nothing but a strain. So here we can write it as delta R by R by S. So this is the strain gauge factor. Now here the strain gauges are two types of strain gauges are there. One is bounded wires, one is bounded strain gauge and another one is a unbounded strain gauge. So what is bounded strain gauge? If the now here if you see here grid of wires are resistance are connected here. So fine resistance is connected in the form of grid is called the bounded wire. Now here this resistance, this wire is cemented on the base. That base may be a thin paper or the base may be the thin bakelite sheet. Now this wire is mounted or this wire is cemented or pasted on the bakelite sheet or paper. Then that is called the bounded strain gauge. Now here you can see this is the diagram for the bounded strain gauge, and after that this wire is covered with the thin metal so that this wire should not get damaged when the strain is applied. Now this is about the bounded wire, bounded strain gauge. Now coming to the unbounded strain gauge, now here if you see this is the fixed base and this is the movable arm or armature. Now here that wires are, resistors are, conductors are connected like this. So these are the nothing but what? Stretched unbounded strain gauge wire. These wires are connected and these four wires are equal length. When the force is applied, the length of the wire will change. The length may increase or it may decrease. So it may expanded or it may compressed. So depending upon the force how we are applying. So thereby what? Resistance will change. That resistance will be again calculated in the form of voltage by using the bridge. Now here these wires are not pasted or cemented on the base. Now here the wire is fixed here. It is not bounded, it is unbounded. Wires are connected like this. So when the pressure is applied, when the force is applied, then the length of the wire will change. So only the difference is what? Here this wire is cemented or pasted on the base. That base may be paper or bakelite sheet. Now here it is not cemented. So this is the difference between bounded and unbounded strain gauge. So now this is about the LVDT and strain gauge. Thank you. In the next lecture we will study the thermocouple and block diagram of instrumentation system.